We're going to begin section 6.2 with a look at how we distribute two polynomials into each other. So recall that I would multiply x by both parts of the second parenthesis, then come back and multiply 4 by both parts of the second parenthesis. So the distributive property would give me x times x is x squared, plus x times 3 is plus 3x. Then start with the 4. 4 times x is 4x. And 4 times 3 is 12. Okay. What we're going to be looking at in this section is how to undo that process. Let's study it for a second. Once I combine my like terms, I have x squared plus 7x plus 12. Alright, so the coefficient of x, the 7, is the sum of the first and last terms, the 4 and the 3, right? Because I get those two middle terms and I add them up and have this sum as the coefficient of x. Alright, then the constant term, the 12, is the product of the last two terms. And we're going to use those properties to factor something back from the expanded line up to the parentheses. That's our goal right here, is to factor a trinomial that looks like this. Looks like x squared plus a number of x plus a constant back into two binomial parentheses. Okay, so what we need to do then is to find two numbers that multiply together to give c and add together to give b. So c being the constant term and b being the coefficient of x. If we can find those two integers p and q, then the polynomial is going to factor into x plus p and x plus q. As you can see from the example above, our p and our q would have been 3 and 4. 3 plus 4 is 7, and 3 times 4 is 12. Let's take a look at how that works. Alright, I am always going to start with the constant, the last number, 28, and factor it to see how many times or how many ways I can get things to multiply together to be 28. So for example, 28 is 4 times 7. Now, I already know that 4 times 7 is 28, so I want to figure out what 4 plus 7 is to see if I get that middle term. So 4 plus 7 is 11, so those two numbers are going to work. So my answer here should be x plus 4 and x plus 7. Now let's go ahead and check it. Just verify that this works. X times x is x squared. X times 7 is 7x. 4 times x is 4x. And 4 times 7 is 28. So when I combine my like terms, I get x squared plus 11x plus 28. So let's talk a little bit, before we go on to the next one, let's talk a little bit about why this works. Okay. One of the reasons that this works is this is a polynomial of the type that it begins with x squared. Because it begins with x squared, I know that the only way to multiply to x squared is x times x. So my x plus p, my x plus q, is going to have that constant piece right there, that x leading it off, to get that x squared. Okay, and then the other piece was, I start with the 28 because there's only a certain number of ways of multiplying to 28. 4 and 7, 2 and 14, 1 and 28. There's only 3 different ways of multiplying to 28. I don't want to start with things that add to 11 because there are millions of those. 1 and 10, 2 and 9, 3 and 8, negative 2 and 13. I could go on and list millions of ways to add to a number, but to multiply to a number there is only a small number. So we always start with the last number. Always start with things that multiply to 28 and try to find a set that adds to the middle number. Alright, so let's try the next one. I want to multiply to a negative 24. So I know that in order to do that, I'm going to need a negative number and a positive number. So I know that 6 times 4 is 24, and I just said I would make one of them positive and one of them negative. I'll make that note up here. 1 positive and 1 negative. Okay. It doesn't really know which one is supposed to be positive, which one's supposed to be negative until I see what they add up to. Right, 6 and 4 add up to 2, which is not what I want, so let's try again. 24 is 12 and 2. That adds up to 10. It's also not what I want. Also, 8 times 3 is 24, and that adds up to 5. That's very close, but I don't want a positive 5, I want a negative 5, so now we know that it was supposed to be a negative 8 and a positive 3 to make the 5 negative. Okay, so we find the set that we want, two numbers that multiply to the negative 24 and add to the negative 5. So we know that the answer is x with a negative 8, so x minus 8, and x plus 3. And again, we could check it by multiplying it back out and showing that it multiplied out to x squared minus 5x minus 24. Okay, let's go to the next page. Okay, so some tips here. Anytime I have a positive last number, a positive constant, like a positive 12 or a positive 20, I know it's going to be two of the same types of numbers. The only way to multiply to a positive is with two positives or with two negatives. Now I know even more than that based on the middle number. If I need two positives or two negatives to add up to a positive, it's going to have to be two positives. If I want them to add up to a negative, it's going to have to be two negatives. Okay, so just by looking at the signs of these numbers right here, I know that I'm looking for two positive values in the first example and two negative values in the second example. That's going to be handy for helping me to factor this. So let's go ahead and take 12. Let's break it up. We're looking for two positive values. So 12 is, I need to multiply to 12, not add to 12. So I multiply to 12 with 2 and 6, two positives. 2 plus 6 is 8, that doesn't work. Or 3 times 4, and 3 plus 4 is 7. That's the one I need because it adds up to the number that I was looking to get. So the answer, the factorization, is x plus 3, x plus 4. Alright, and the next one, I need to add to a positive 20, and I need two negative numbers now because I need them to add to a negative 9. So two negative numbers will multiply to a positive and will also add to a negative. So negative 4 and negative 5, the two negatives, the numbers that will multiply to 20. And when you add them up, you get negative 9. So that worked on the first try this time. So x minus 4 and x minus 5 is the factorization. Okay. Now with a negative last number, okay, if the last number is negative, we know we need one positive and one negative. So let's try a couple of these. Negative 16, the only way to multiply to a negative is with a positive and a negative. So positive and a negative, so 2 and 8 go into 16. Which one needs to be positive, which one needs to be negative? If it's going to turn out negative, it better be the bigger one that's negative. So 2 minus 8 is negative 6. So the answer on this, that's correct. That's what we needed to get. So it's going to be x with a positive 2 and x with a negative 8. Alright, on the next one, a negative 24, so I need one positive and one negative again. 24 is 6 times 4. And if I want this to be a positive value, it better be the smaller number that's negative. 6 minus 4 is 2. That is the value we wanted. So my factorization is x plus 6 and x minus 4. Let's practice factoring in a couple more examples. In this one, I start with 12. It's a positive number. I need it to add to a negative, so it's going to have two of the same, two negatives. So 12 is 2 times 6, 3 times 4. So I know that 2 times 6 is going to add up to negative 8. That's not going to be what I need. 3 and 4 will add up to negative 7, and that is what we need. So that's going to be the correct factorization. So it's going to be x minus 3 and x minus 4. It really helps to show your work, to show what things that you've tried, as well as the correct answer, because you don't want to try things more than one time, so you don't want to keep going over those same numbers and working with the same numbers. And also, if you aren't able to come up with the correct answer, at least showing that you tried a couple answers is going to get you some partial credit when you're working problems by hand. Okay, so I'm going to try the next one, negative 18. I know since it's a negative number, I'm going to have one positive and one negative, and the larger number is going to be the positive since I want to have a positive sum. Okay, so 18 is 3 times 6. I want the larger number to be positive, so I'm going to write it like this, negative 3 and 6 gives me a 3. That's what I wanted. I got it on the first try this time, so I've got x minus 3 and x plus 6. Okay, what about the next one? In the next one, I need to get a 10q, but I'm going to work primarily on the 10 right now. It's a positive number, so either two positives or two negatives. I can see that they need to add up to a positive, so it's going to be two positives. 5 and 2 make 10, so 5 and 2 add up to 7. That's what I want as well. What to do with the extra q? We know that p times p is going to give me p squared. And we know that if I put my 2 positive and my 5 positive, we're going to get the 10, but I don't want just 10, I want 10q. Oops, I didn't mean to write a p right here. I meant to write a q. So this needs to be p plus 2q and p plus 5q. Now let's just check it to make sure that that pattern works. P times p is p squared. P times 5q is 5pq. 2q times p is plus 2pq. And 2q times 5q is 10q squared. When you combine your like terms up here, you will get the 7pq. So I just wanted to verify that this pattern of p's then q's will make this p, pq, q squared result. So having a variable at the end and the middle, an extra variable, is no problem at all. We're just going to make sure that when we put in our 2 and our 5, we put a q with them. The q times the q is the q squared, and when you make your mixed terms, the p times the q is going to give you that pq in the middle. Alright, so let's look at the next one. This one has a negative 32, so I know I need one positive and one negative. And the negative is going to be the larger, because there's a negative sum in the middle. Alright, so 32 is 8 times 4. Alright, and we said the negative one needed to be the larger, so it would have to be a negative 8 and a positive 4, and that does give me a negative 4. So when I factor this, it'll be x minus 8y and x plus 4y. Again, we needed this to have a y at the end because I have a y squared at the end. And when I multiply my middle terms together, it will correctly give me xy terms. Alright, now for the next one, I'm actually not able to begin factoring right away because of this 5. If you remember from the previous page, maybe one more page back, the type of factoring that we are currently doing is x squared factoring. It's very important when I'm factoring these that it is x squared by itself. That's the first term. That's what allows me to make this x times x in the first position and why I can factor in this pattern. I can't do that with this example, so I need to do something else. Okay. I'm out of time, so I'm going to start that something else in the next video, but just keep in mind that that is something different when I have a coefficient like that.